Okay, so set 32, we're going to take two things you guys already know how to do and mash them together into one problem, which is pretty much all we're going to do for the rest of the year. Okay, so on your paper where you're going to do set 32, will you just write down this mathematically for me, please? No. Don't write it all out in words. Write it mathematically. Felicia.
Cadence. Or Gracie, whatever one.
Okay. Yeah, write it mathematically. Not the way I have it. Okay, you got it?
No.
So what does the sum mean? Yeah, it means we're going to put two numbers together, right? Okay. And what two things are we going to put together? Twice a number. How do we write that? 2n. And 13. And what are we supposed to do with those two things? Add them together. Okay, so that's what you have. And that's what we've been practicing the last 2 or 3 assignments, right? Okay? That's not new. Now, here's the new part. I'm going to add a little bit to this. Ready? Oh, by the way, is this an equation? Can you solve it and find n? No, it's not an equation. It doesn't equal anything. You can't solve it and find n. You've just been writing this down, right? Okay, now, here we go. Here's the good part. Now, notice I just put a period at the end of this sentence now. It's a complete sentence now, isn't it? Before, it was just an expression. Now it's a complete sentence. So when you complete it down here, what does is mean? Okay, everybody equals 75. Now we have an algebraic sentence, not just an algebraic expression. So this is a sentence, it's an equation, and can we now solve it? Yeah, we can solve it. Solve it. Everybody solve it. Just take a second. I got 31. What'd you get? 31. All right, I did it right. Okay.
Oh, I got 31.
So this is what's going to happen now. We're not going to just give you, well, they're still going to give you some that are just like this, and you just have to write them down. But then they're going to give you some that are complete sentences, and they're going to say solve for n or find n. So you actually have to solve the equation after you write it down. Okay? So this is the kind of the first step in really looking at a real type of problem and being able to use mathematics to do something good. Okay, so I better write this whole thing out for you. Find a number such that 13 less than twice the number, not mumber, number is 137. So here's the important bit. Can you write that mathematically? 13 less than twice the number is 137. Remember, this is the tricky bit to get 13 less than something. Like if you wanted 13 less than your age, how would you do that?
I'd be 2.
You'd be 2. So you didn't start with 13 and subtract your age, did you? You started, okay, so that's the same thing here. We can't start with 13 and subtract twice the number. If we want 13 less than twice the number, we've got to start with twice the number and subtract 13, don't we? Okay, and what does this mean? equals 137. Solve it. That's an equation now. You can do it.
Yes, we can.
Okay, what'd you do? Did y'all add 13 to both sides?
Yeah.
These canceled? 2n equals 150? Divide both sides by 2? 1n equals 75. That's our number? Okay.
I got it right.
Okay. Okay, I wrote this other one out while you guys were working. It's horrible. It says, find a number such that if 5 times the number is decreased by 14. Okay, let's just concentrate on that bit right there. 5 times some number is decreased by 14. Can we all write that down? Nikai, how do you write 5 times a number? Okay, like this, right? Okay. Riker, how do you decrease it by 14? I always call you your brother's name. We subtract 14, right? Gracie Mills, it says the result is. What do you think you're going to put when it says the result is? Good choice. Equals. Okay? Twice the opposite of a number. Remember, that's kind of the weird one, isn't it?
Yeah.
So technically it's twice, that means 2 times, the opposite of a number, but we're kind of cheating and going right to the end result of this, which is twice the opposite of a number. Okay? Now this one's a little bit of a thing to solve, but I think you can do it. Let's see, parentheses? Yay, no parentheses. Like terms? Yay, no like terms. Variable on both sides? All right, let's get rid of the variable from one side. Which one do you want to get rid of, the 5n or the negative 2n? Good choice. I think the 5n, because that way we have the constant on one side and the variable on the other, right? Now we can just divide both sides by -7. And I ran myself out of room, sorry. So our number turns out to be positive or negative? Positive. Yeah, positive 2. If that's positive, these all cancel. So 1n equals 2. Okay, everybody turn to page 132.
Oh, yawn.
All right, do practice A, and I'll walk around and help you. Right there at the bottom of the page. no. I'm looking at you. You're not even looking at the problem I'm trying. Come on. You can write down 4 times.
I know.
Write it down.
I was just taking a break.
No breaks. Here, 4 times the number. Write it down. Simple. Decreased by 8 equals 92. Let's solve it. That's it. Good. Good job. Okay. So 4 times the number. We all know. I hope. 4 times the number, right? Decreased by 8. And it equals 92. Is that something we can solve? Sure. We can add 8 to both sides. 4n equals 100. We can divide both sides by 4. And our number is... Does it actually work? Does 4 times 25 subtract 8 actually equal 92? That's the number that works, right? Okay. Now, practice B, not quite that easy. The product of 4 and a number is decreased by 12. Let's all just try to write that down. The product of 4 and a number is decreased by 12. Okay, Ryan, what'd you put?
4 and minus 12.
Okay. The result is, what does that mean? The result is?
Equals.
Okay, it equals something. Okay. Twice the opposite of that same number. So, Easton, what do you think about twice the opposite of a number?
Negative.
Negative. Negative what? What does twice something mean?
2.
2 times it. And 2 times what? There you go. 2 times n. So there's twice the opposite of that same number. Okay? Cadence, how do you want to solve this thing? How do you want to start? Good choice. Yeah. If we subtract 4n from both sides, she says to do that, we're going to have our constant here. Don't forget our negative, right? And then it equals negative 6n. We don't end up with 0 on one side, do we? Okay. Yeah, and then make sure we divide by negative 6, so that, what do we want right here? What do we want the coefficient of n to be? Positive 1, right? Positive 1n equals positive 2. Okay, let's go back and talk a little bit more about some graphing stuff today. We started out yesterday doing a little bit of graphing, and I want to put some on the Alex assignment for you. So first of all, let's think about that equation we did yesterday. It looked something like, I can't remember what it looked like, 2x plus 8 times 3 equals negative 6, something like that. Can we solve this? Hey, up here. What do you want to do first? Okay, so 6x plus 24 equals negative 6. Okay, subtract 24 from both sides. Yeah, I like to hear that, from both sides. So this is 6x equals negative 30. Yeah, divide both sides by 6. And x is negative 5?
Yes.
Okay, negative 5. So I'm just going to start with this equation. We had it part way solved. And I showed you this yesterday, but I'm going to solve for 0. Okay? Did you remember yesterday? I know it's a long time ago for you guys. Can I make it say 0 right here? Who says yes? Who's not listening? Yeah, that's what I thought. Okay, pay attention. Who thinks I can put 0 right here? By doing what? Yeah, adding 6 to both sides. So 6x plus 30 equals 0. Okay? And then this might bother you guys, but I'm going to divide both sides of this equation by 6. I'm going to divide that term by 6. I'm going to divide this term by 6, and I'm going to divide that term by 6. I'm going to divide every term on both sides of the equal sign by 6. Will it still be equal?
Yes.
Sure, as long as I do every term on both sides. So what does this give me? X plus 5 equals 0. Okay. Now right here where the 0 is, I'm going to replace it with a letter. Remember the letter? Yeah, I'm going to replace it with a y. And I might even write it this way. Oops. This way. Y equals x plus 5. And that's what we're going to graph. Y equals x plus 5. Y equals x plus 5. We're going to make a table. This is how we're going to graph for a while. And we're going to put a number in for x. Like, think lazy.
1.
Lazier.
2.
0. 0. Yes, we're going to put a 0 in. What is 0 plus 5? Okay, and we're going to graph that point. Make sure you put 0, 5, not 5, 0, 0, 5, okay? And then I'm going to put a different number in for x, like?
2.
Yeah, I'm not going to go with 1. Remember, we don't want the points to be too close together because sometimes it gets too scrunchy. So at least a 2. So I'm going to put a 2 right here, plus 5. That gives me 7. So I can graph 2, 7. And then since I put a 2 in, it's easy to put a negative 2 in. I'll just change that to a negative. And negative 2 plus 5 is? So negative 2, 3. And I can graph my equation. Okay. Now, last year you guys talked a lot about the y-intercept, didn't you? What's the y-intercept?
Where the line crosses y.
Right, and in this case specifically it is the number 5, right? But I want to talk now about the x-intercept. What's the x-intercept? Negative 5. Do you remember our original equation? I feel like I'm revealing a magic trick, but I'm not. Remember the solution to our original equation? Negative 5. And when we turned it into a linear equation we could graph, and we graphed it, where does it hit the x-axis?
Negative 5.
Coincidence?
I think not.
I think not.
That's all.
You have to say that. Yeah, it's not a coincidence. That's the solution. Okay, why do we call this a linear equation? What? All the points that satisfy it, what do we know about all of them?
They're in a line.
Yeah, they're collinear. They line up. They're collinear. So if someone else at a different point, like if someone else put a 4 in, and they went 4 plus 5 is 9, and they graphed the point 4, 9, would the world still be fine that way?
Probably.
Sure. They're not probably. They're all going to line up, aren't they? Okay. So this is the way we're going to graph for a little while, and one of the reasons for this is you need to understand how to make a table to graph things, because you're going to run into equations that aren't linear, and you got no idea what they look like. Okay, so you might run into an equation like this. Now, is this a linear equation?
Yes. No.
No. X squared.
That's 2
It's not a line,
Yeah.
right? It's some other shape. Do you know what it looks like? Do you have any clue how to graph it?
Not too bad.
But look, it doesn't matter how complicated the equation is. You can go, well, what if x were a 0?
Then it'd be a 0.
Y would be a, what if x were a 1?
Y would be
What if x were a 2?
4.
4. What if x were a 3?
6. 9.
Okay, I'm gonna say a number, and you guys are gonna think first and then say the answer. Okay, now be careful about this one. In fact, I'll even do this. What if x were a negative 1?
1.
Positive 1.
Isn't that weird? You put in a 1, you get out a 1, you put in a negative 1. What would happen if we put a negative 2 in? Positive 4. What if we put a negative 3 in?
Positive 9.
Okay. If you get enough of these points, then you can start graphing and see what the heck this thing looks like. So if we graph these points, I'll do this one in red, 0, 0, and 1, 1, and negative 1, 1, and 2, 4, and wasn't it 3, 9, and negative 2, 4, and negative 3, 9, and you start to get an idea about what that equation looks like when we graph it. Hello. Sure. Gracie Huntington. It's your mom. I think you're in trouble. Okay. So, we always want to be able to know how to do this. Even when you get into calculus, okay, you're going to run into equations and, you know, they might look like this, you know.
What's that called again?
This is called a sine curve. And you don't know what they look like. And so by being able to make a table of values, you can graph them and figure out the general shape and how it looks. And everybody has to be able to do this. So there you go. So tomorrow, probably 25, 30 problems on the ALEKS assignment if you work hard from now to the end of class. Go. Get after it. Set 32.
How about 10 questions for $20?
It costs more than that.
I don't know, $20.